Alright, back when we were dealing with imaginary numbers back in chapter 5, what would happen is if we got an I in our denominator, what we had to do is we had to rationalize it. In order to do that, though, if you had a binomial, you had to use what we called the conjugate. So you can use the conjugate, that's supposed to be no. You can use the conjugate to rationalize denominators that include binomials. The product of conjugates is always a rational number. Okay, always rational number. The whole purpose of multiplying by a conjugate is so you get rid of your radicals in the bottom. So if we look at 6a here, we have a 5 plus radical 3 in the bottom. We're going to need to multiply top and bottom by a 5 minus radical 3. So when I talked earlier, when we were multiplying a difference of squares, this is going to come in handy here on the denominator because you are not going to have any radicals left over. So if we multiply on the top, we're going to have to FOIL. So if we FOIL here on the top, you're going to take a 1 times a 5. So if we multiply on top, this 1 times a 5, we will get a 5. If we multiply 1 times the radical 3, we get a negative radical 3. Then we have to take the negative radical 3 times the 5. That'll give us a negative, man, this handwriting is horrible, sorry. Then that will give us a 5 radical 3. That's supposed to be a 3. And then if we take radical 3 times a negative radical 3, we will get a positive. This will be a square root of 9, which is a 3. Remember, anytime you multiply a radical by itself, you get itself. On the bottom, we are going to take the difference of squares. So we're going to multiply this 5 times the 5, which will give us a 25. And then we're going to have a minus sign. And then we're going to take radical 3 times radical 3, which gives us just a 3. Just like it did above when we multiplied a radical 3 times radical 3. So what we're going to end up with here when we simplify everything, we can combine like terms on top. So we have 5 plus 3 is 8, minus 6 radical 3. And on the bottom we have a 25 minus 3, which is 22. Now the only issue here is we have to make sure, by using your rule of 3 idea, that if you have anything that has a common factor, such as 8, 6, and 22 are all even numbers, they can all be divided by 2. So your final solution ends up being 4 minus 3 radical 3 all over 11. And that is your solution for example 6a. Now, same concept happens on B, even if you're multiplying by an expression. An expression has variables and numbers. So, in this case, what we're going to do is we're going to multiply top and bottom by a square root of y plus 1. So on top, we're going to need to FOIL. We're going to multiply a y on the outside times a y on the inside. That will give us a y, radical y. Then if you multiply y times a 1, that's going to give you a y. If you multiply 3 times radical y, that gives you a 3 radical y. And then a 3 times a 1 gives us a 3. And then finally on the bottom, you're going to take your square root of y times your square root of y, which will just give you a y, minus 1 times 1, which is 1. And then what you do is you look to see if you can simplify anything on top. You could try adding together a y radical 3 and a y radical y and a 3 radical y, but you're not going to be able to simplify anything there. So what you're going to do is this is going to end up being your final solution. And that is how you use conjugates to rationalize the denominator.